Alright, so welcome back to another video of this YouTube channel of Algebra 2 here at Sunset High School. Today we're going to do a lesson on rational exponents. And we did something before, so you know what is the meaning of 2 to the power of 3, right? It means that you need to multiply 2 by itself 3 times. So we get 2 times 2 is 4, times 2 is 8. So we know that. But what happens when we want to do 2 to the power of 1/3? It means that you need to multiply 2 by itself, but only 1/3 of a time. And that is weird. So we don't really understand what is the meaning of that. But we know a rule that if we have a fractional exponent, we can rewrite as a radical. So, an example. 2 to the power of 1/3 is the same thing as the cubic root of 2. Or, let's say that I want to do 16 to the power of 1/4. So if I rewrite as a radical, it's going to be the root with index 4 of 16. And the answer for this one is going to be 2, because 2 to the power of 4 equals 16. So we're going to do problems like these ones, and then we're going to try to simplify expressions with radicals. So let's go, keep going. Alright, so just we are going to do like a few examples of how to convert in between exponents, rational exponents and radicals. So this is just going to be index 4 of x, or this is going to be index 4 of x. Let me do this one like in a different way. So this is really going to be x to the power of 1/4 to the power of 3, right? Because if I multiply by 3, I get 3/4. We know that x to the power of 1/4 is the index 4 of x, and everything to the power of 3. And then these exponents can go on top of x. So really this is the radical of index 4 of x to the power of 3. Following the same idea, the next one is going to be the radical index 7 of x to the power of 6. And the last one is just easy because it's x to the power of 1, right? The index is going to be 5. In general, if I want to do x to the power of a over b, I will get the radical index b of x to the power of a. So the number of top is the exponent, and the denominator is going to be the index. So we can use this property to find the answer to some problems, right? Like this one. So what is 16 to the power of 1/2? It's going to be the square root of 16. Because remember, if the index is 2, we don't write it, right? So this is going to be 4. What is going to be 8 to the power of 2/3? So this is going to be the cubic root of 8, all of it to the power of 2. The cubic root of 8 is going to be 2, and to the power of 2 is going to be 4. And this 125 to the power of 1/3 is going to be the cubic root of 125, and it's going to be 5, right? And remember, this is because 5 to the power of 3 is going to be 125. And the last one is 81 to the power of 3/4, so we put 81. The index is the denominator, so it's going to be 4, all of it to the power of 3. The root with index 4 of 81 is going to be 3. So this is 3 to the power of 3, and it's going to be equal to 27. So you can really apply these rules to find the answer to questions that are weird, if you think about it, right? Now we're going to do questions on how to simplify. So, you can do this thing in different ways, but I think I will explain a way that I like. So let's see that I want to do something like a to the power of 4, the square root of this, right? So I need to apply the properties that I know to simplify the expression. So if the index is 2, this is like a to the power of 4 to the power of 1/2, right? And then remember that I need to multiply the exponents. So this is really like a to the power of 4 over 2, or a to the second. So really what I'm doing is what it says right here. What I'm doing is I'm dividing the exponents by the index. Remember, when I don't put anything, the index is 2. So this first question is going to be a, and I just write the exponents over the index. So a to the power of 4 over 2 times b to the power of 8 over 2 times c to the power of 10 over 2. And if we're lucky and all the fractions give me whole numbers, I just write the result. So a to the power of 2 times b to the power of 4 times c to the power of 5. And this is the answer. You just need to simplify it. Remember, we divide the exponent by the index. Next question is going to be a to the power of 6 over 2 times b to the power of 2 over 2 times c to the power of 12 over 2. And this is going to be a to the power of 3 times b. 2 over 2 is 1, so I don't need to write anything, times 2 to the power of 6. Something is going to be different if the numbers that I got when I do the fractions are not whole numbers. So something is going to be different with this one, b to the power of 5. We'll set it up the problem in the same way. So a to the power of 4 over 2 times b to the power of 5 over 2 times c to the power of 10 over 2. So if I can divide and I get a whole number, I just leave it like that, right? Okay, then 5 over 2, if I divide, is going to give me, the answer is going to be 2, and the remainder is going to be 1/2, right? So this is like thinking about mixed fractions. How do you do 5 over 2? It's going to be 2 1/2. So I cannot split the whatever is b with the exponent in 2. And then the other one is going to be c to the power of 5. So everything that is whole numbers goes in front. So a to the second, b to the second, c to the power of 5, and I have b to the 1/2, right? So a to the second, b to the second, 3 to the power of 5, but we know that b to the power of 1/2 is just the square root of b. And now I got the answer. So I try to move everything that I can out of the radical, and if I have remainders when I do the divisions with the fractions, they get inside. This is easy to understand if we're looking at more examples. So let's see if I want to do cubic roots. So the idea is the same, right? The same thing. You need to divide the exponents by the index. In this case, we need to divide the exponents by 3. So this is going to be a to the power of 12 over 3 times b to the power of 6 over 3 times c to the power of 3 over 3. First question, we're lucky, everything is whole numbers, so there's going to be a to the power of 4, b to the second, times 3. Not a problem on this one. Next one is going to be a to the power of 9 over 3. this is a 9. B to the power of 3 over 3, C to the power of 15 over 3. So it's going to be A to the power of 3, B to the power of 1, so just B times 3 to the power of 5. Alright, in the last one, I have a 4, that is not a whole number. If I divide by 3, same thing will happen with a 5 and with a 10. So, I just need to do the division, right? Set up the problem, so we know how to do this. Alright, and then I need to be careful when I divide. So 4 over 3, the answer is going to be 1, and I have the remainder of 1, so it's 1 over 3. B is going to be, the answer is 1, but the remainder is 2. And the last one is going to be C. 10 over 3 is going to be 3, right? The remainder is going to be 1. So everything that goes with whole exponents is going to be outside. So it's going to be A times B times 3 to the third. And then what is going to be inside the cubic? The remainder. So it's going to be A with the remainder of 1. So A. B to the second times C. And I mean, that's how you do it. So I think I made a mistake, and the last one is not B. This is going to be a C. So sorry about that. Okay, so everything that is whole numbers, these numbers, they go outside, right? And everything that is, and the remainders, they go inside, right? So the 1, sorry, right? So this one, the 2, and the other one. All right, so let's do like another one with a little mix of exponents at different index and different things. Okay, so in the first case, the index is going to be 4, right? So we do 4, 12 over 4 times y to the power of 7 over 4. And we just do the division, right? So 12 over 4 is going to be 3. There is no remainder, so we're lucky. And the next one is going to be y. So the answer is going to be 1. And the remainder is going to be 3. So what is the final answer? X to the power of 3, y. And then the root is going to be index 4 of y to the third. That's the answer. So this is the point. The point is try to get rid of the radical as much as we can. Alright, the next one, let's do this one. So it's going to be x to the power of 12 over 3 times y to the power of 7 over 3. And it's going to be x to the power of 12 over 3 is going to be 4. 7 over 3 is going to be 2 with a remainder of 1. So the final answer is going to be x to the power of 4, y to the second, and the cubic root of y. And then let's do the last one to finish. Remember, no number means that the index is 2. So I need to divide over 2. This is going to be x. So this is going to be x to the power of 12 over 2 times y to the power of 7 over 2. And it's going to be x to the power of 6 times y to the power of 3 with a remainder of 1. So it's x to the power of 6, y to the power of 3 times the square root of y. Okay, like everything in math, there are more ways of doing this. So we can do this in different ways. And I will show you like a couple of different ways of doing it, okay? So maybe you understand this one, you're good and you're ready to go. But another way of doing it is this one. Okay, so let's see how, I will show like a couple of different ways of doing this. So you can, well, let's make up like a problem. So let's try to find index, right? Index 3 of x to the power of 5 times y to the power of 4. So you can do this. You can just use the properties of powers, right? So x to the power of 5, I need to multiply x 5 times by itself, right? And the y 4 times. And then if the index is 3, you're going to try to make groups of 3, right? So I can do 1, but with these 2x, I need like an extra 1, so I cannot do that. I cannot do that. And I have like another one with a y, right? So what is the answer? The answer is, how many groups did I did with the x? I have only one group, so that will be x. And with the y, I have another one. And then whatever is I couldn't group is going to stay inside the radical. So it's going to be x times x, that is x squared times y. So this is another way. This is like a way of doing it that people sometimes understand better. This is like a I don't know, you can call it grouping or something like that. And another way of doing it is, let's say that you want to do 3, right? Index 3, let's put x to the power of 8 times y to the power of 5. So you can do this thing. The point is you try to cancel out radicals, right? And we're going to apply it. So we will cancel out one radical if we have the same exponent as the index, right? Because this is really x to the power of 3 over 3. It's going to be x. So you need to find a way of getting the same index and the same exponent. So you do this. So how do you get, what happens with 8? You can get 1 3, another 3, and a 2, right? Because 3 times 3 plus 2 is 8. And with the y you can do 3 and 2. So what can I cancel out? I can cancel out 1x, 1 3, 1 3, and 1 3, right? So x times x is going to be x squared. I have 1y, and then whatever is left is going to be inside the radical. X to the second, y to the second. So the point is that you can do this in different ways. So I don't know, hopefully you enjoyed the video, you understood what we're doing, and we will see you in the next one. So thanks for joining, thanks for watching. We will see you in the next one.